Humanity has long sought to learn about the Milky Way, our home galaxy. Even after the advent of optical telescopes, the Milky Way center, some 26,000 light-years from Earth, remained mysterious because gas and dust block most visible light along our line of sight. Fortunately, X-ray telescopes, like NASA's Chandra X-ray Observatory, can detect higher energy radiation that penetrates this veil of galactic debris. Since Chandra was launched into space in 1999, it has observed the center of the Milky Way many times. And what it has found is no less than revolutionary. A supermassive black hole weighing about 4 million times the mass of our Sun sits at the center of our galaxy. Astronomers call this black hole Sagittarius A-star, or Saj A-star for short. Sagittarius A-star sits in a complex and dynamic environment surrounded by stars, hot gas, supernova remnants, and more. Professor Daryl Haggard of McGill University in Montreal, Canada, has been one of the leading researchers in using Chandra to learn about the heart of our Milky Way.
We use Chandra to study the galactic center because Chandra is sensitive to X-ray photons. These are very high energy photons, and they are very excellent at penetrating through gas and dust. And when we look at the galactic center, because we live in the Milky Way galaxy, we live in the plane of the Milky Way galaxy, and we're trying to look right into the middle, that means we have to look through so much gunk, all this gas, all this dust, lots of intervening stars. And so we really need X-ray photons to be able to penetrate all of that gunk in the galaxy so that we can see right down into the center where the supermassive black hole, which is called Sagittarius A-star, resides.
Among some of the interesting things Chandra has seen are flares or outbursts in X-ray light from the Milky Way's giant black hole.
We did not expect to see these flares. They were completely new phenomenon that were revealed to us by Chandra for the very first time. So I think if there's only one thing that you think Chandra has really showed us about the galactic center and about Sagittarius A-star, it's that it has this very unusual outbursting flaring behavior. So now 20 years later, 20 plus years later, we're still studying those flares and trying to understand what they mean and exactly where they originate, how close to the supermassive black hole. So this is still a mystery that lives with us today, but Chandra was essential for understanding that that flaring behavior was coming from the supermassive black hole itself.
While Chandra has helped make many discoveries about black holes, including the one at the center of the galaxy, its work is far from over. Rather, astronomers are using X-rays from Chandra and combining them with data from other telescopes, including the Event Horizon Telescope, to learn more about black holes, both in our own galaxy and throughout the universe.
I think the most exciting thing that we're working on very actively right now are studies using Chandra plus other observatories. So a joint observing campaign, for example, with the Event Horizon Telescope, or with the Fermi Telescope, or with SWIFT, or the VLA. Sometimes when we're really lucky, very successful, we actually get all of these resources looking toward the galactic center all at the exact same time. So it's very difficult. You're talking about coordinating observatories in space, observatories on the ground, observatories that are looking at every different wavelength and that are spread across the globe and above the globe. And so this is a lot of work on the behalf of a lot of different people. But when we do that, what we can start to figure out is how the total energy budget, all of the light coming from the supermassive black hole, how it looks in a single snapshot, and how those snapshots change as a function of time.
Astronomers put in this kind of work because the results can tell us more about the science of what's happening right down to the edge of a black hole itself.
And this allows us to really understand exactly which things are coming from right next to the event horizon of the black hole, what's happening just a little bit outside of that event horizon. Are the flares themselves, those bright X-ray flares, do those come right next to the event horizon, or are they just a little bit further away? And when we compare observations from multiple observatories, including the Chandra X-ray Observatory, we get that extra bit of insight to understand all of the environment, all of the surroundings for the gas and the dust and the material that's trying to flow in or trying to fly back away from the black hole itself.
Clearly, there is much to explore and learn about our home galaxy, the Milky Way. And Chandra will continue to be an important tool in that effort.